Okay, let's move to section 1.5. All right, we're going to deal with linear equations, functions, and zeros. Okay, so we have to talk about what that means, right? So when we talk about an equation, okay, when you think about the word equation, you should think of something equal to something else, okay? Two things that are equal to each other. All right, so this does not necessarily have to be numerically equal to each other, just anything that's equal, okay? But in math, typically we're dealing with numbers or variables which are represent unknown numbers, right? So equation is an equality, okay? Expressions that are equal to each other. When we say solve an equation, we are talking about finding unknown variables, right? Unknowns that make the equation true, right? Finding the unknown value that makes the equation true. So for example, 3x equals 6, right? 3 times x equals 6. Well, we'd solve that by finding the value that makes it true, the value for x that makes it true, which would be 2. Okay, so we'd say that 2 is the solution, right, which is the result of solving the equation. Okay, whenever an equation has multiple solutions, or just one, we would call the list of them a solution set. Okay, so for example, let's move to a different example. X squared equals 4. Well, x could be 2, right? Because 2 times 2, 2 squared is 4. But x could also be negative 2, because negative 2 times negative 2 is a positive 4. Okay, so if I listed out both of those, we would say that is a solution set. Okay. All right, so now we're dealing with linear equations, and those are equations that involve only one x, right? Only one variable, one solution. Okay, so let's go on to solving one. So let's see, 2x plus 3 equals 5. Actually, we're not solving this one. I'm given 2x plus 3 equals 5, and I'm told x equals 1, and I want to find out whether or not these two are equivalent. Okay? Are these equivalent? In other words, is x equals 1? Is 1 a solution for this equation? So I'll just plug in 1. 2 times 1 is 2. Plus 3 equals 5. Yep, 5 equals 5. Check, right? So 1 actually is a solution. Okay? So that's what solutions do. They make the equation true. Let's see about a second example. Here's x squared minus 3x plus 2 equals 0. Okay, let's see if x equals 1 works for that one. Okay, so we'll plug it in. 1 squared minus 3 times 1 plus 2. 1 squared is 1. 3 times 1 is 3. 1 minus 3 is negative 2. And negative 2 plus 2 is 0. So check, we have an equivalent expression. So another thing I wanted to say, this equation and this equation, they're very different, but they're equivalent. They're equivalent because the equality is still true. Okay, let's see. Let's try x equals 2. Okay, same equation. Let's try x equals 2. So that's going to be 2 squared minus 3 times 2 plus 2 equals 0. 2 squared is 4. Negative 3 times 2 is negative 6 plus 2. This one's going to work out as well. Negative 2 plus 2 equals 0. 0 equals 0. So 2 is also a solution. X equals 2 is also an equivalent equation. All right, moving on. Let's actually solve 2y minus 1 is equal to 3. 2y minus 1 is equal to 3. Okay, so to solve that, we actually, and we're not going to talk about this every time, but we apply a list of principles that we kind of take for granted. Okay, certain things that, well, certain things called the addition principle, for example. Which just basically says, okay, if you have some real numbers, A, B, and C, and if A equals B, right, these two numbers equal each other, then if I add something to both sides, I still have a true equation, right? So if A equals B, then if I add plus C to both sides, I add to both sides, I get the same, or not the same equation, but I get a true equation. I get a true equation. Okay, that's called the addition principle. It also applies with subtraction, right? The addition principle is the exact same thing as subtracting from both sides. We just treat addition and subtraction the same way in this case. There's the multiplication principle of equality. And that one says if A equals B, then I'm sure you could guess, if you multiply both sides by the same number, you have the same, or you still have an equality. Okay, so if A equals B is true, then AC equals BC is also true. All right, so those are some principles that we take for granted, but we know is actually true. So let's actually put that into practice. If I'm trying to solve this equation here, I can use the addition principle to add 1 to both sides, knowing that the result is still going to be a true equation. And the equation will look like this, right? The -1 plus 1 cancels, the 3 plus 1 turns into a 4. Okay, that's the addition principle. Then I follow it up with the multiplication, which is also the division principle. All right, multiplication, division, they're the same, if you really think about that for a little while. If I multiply both sides by a half, that's the same thing as dividing both sides by 2, right? If I multiply both sides by a half, I still will have a true equation. It'll just look different. Half of 2 is 1, that's 1y. 4 times a half is 2. So I use the addition principle followed by the multiplication principle to solve the equation. That is what we do every time. Okay, we're using these principles. Okay, all right, let's do some more. Example 4. 10x minus 3 equals 8 plus 10x. All right, so I'm going to first start off by using the addition principle to get the x's on the left side. That's how I like to usually do it. I could technically get the x's on the right side, but I like them on the left usually. So I'm going to subtract away this right side positive 10x. And if I do that to both sides, then it's a legal move, right? That means that my equation will stay true. Okay, so that cancels out, and oh, look at that, cancels out there as well. I'm left with -3 equals 8. Okay, so we have to kind of dissect what that means. Okay, remember what the addition principle said. It says that if A equals B is true, then A plus C equals B plus C is also a true statement. Okay, if the first one's a true statement, then the last one's a true statement. Well, this is not true. -3 is not equal to 8. Well, we use the addition principle. Well, that just means that this original equation was never true to begin with. Okay, it doesn't happen. So, okay, how do I interpret that? That means that this original equation never had a solution to begin with. There is no solution. It's impossible to make those two sides equal each other. All right. That was fun. What about example 5? -x plus 1 equals 1 minus x. Okay. I have a feeling something similar is going to happen. Let's add x to both sides. It also canceled out the left side. So I'm left with 1 equals 1. Okay, so now this is a true statement, right? This is a true statement. 1 equals 1. which means that this one was a true statement no matter what the x value happened to be. No matter what I plug in, that'll always be true. And you can test it out. Just plug in some numbers. -5 plus 1 equals 1 minus 5. So -4 equals -4, right? It doesn't matter. Let's plug in -3. -3 plus 1 is equal to 1 minus -3. This turns into a plus. That's positive 3 plus 1, which is 4. Those turn into a plus. 1 plus 3 is 4. Doesn't matter what you plug in. That equation will always be true. Okay, so what does that mean? That means that the solution set is all real numbers. And this can be expressed in a variety of ways. You could say all real numbers. The symbol of that, by the way, is this. This symbol just means the set of all the real numbers. Okay, so this is a way you can write the answer. This is a way. You could also say there's an infinite number of solutions. There's infinite solutions. Okay, that's another way you could say it. Okay, that's a special case, right? So the no solution and the infinite number of solutions, those are special cases. Example 6. Okay, 4 times 3x plus 2 in parentheses minus 7 equals 3 in parentheses x minus 2. All right, so we're going to have to use another property here that we haven't really talked about, but it's called the distributive property. Okay, and basically all that one says is if you have a, b, and c that are real numbers, okay, then a, b plus c will equal a times b plus a times c. Okay, so in other words, you take that a and you multiply it times everything in the parentheses. That's what we're going to have to do here. So let's distribute 4 times 3x is 12x. 4 times 2 is 8. Positive 8. Minus 7. Be careful not to distribute that 4 to that 7, right? That's not a thing. Okay, it's not in parentheses, so it doesn't get the 4. Let's do the same thing here. 3 times x is 3x. And 3 times -2 is -6. Okay, so it's looking more like a normal equation now. I'm going to combine some like terms real quick before I apply another principle, right? Because 8 minus 7 is 1, so I can actually just rewrite this as 12x plus 1 is equal to 3x minus 6. Okay, so let's use the addition principle. I want to focus on canceling out that 3x, so I'm going to subtract or add a negative, right? 3x to both sides. 9x plus 1 is equal to, those cancel, -6. Now I'm going to focus on getting rid of this positive 1 here, so I'm going to use the addition principle once again. I'm going to subtract 1 from both sides. I'm left with 9x, those cancel, equal -7. Divide both sides by 9, or if you want to think about it as multiplication, you're multiplying both sides by 1/9. Yeah, but I'm going to just divide. Same thing, right? They really are the same thing, right? I'm multiplying by 1/9, right? It's there. There we go. The 9s cancel out to leave me with x equals -7/9. -7/9. Okay, so when x is -7/9, that original equation is true. Okay, let's talk about zeros. Okay, we haven't mentioned that yet. So zeros. Okay, so what is a zero? Let me see. A number, C, just use the letter C to represent any number here. The number C is a 0. It's also called a root, by the way. I don't think this book uses that word, but you should know root is the same thing as 0. A number c is a 0 of a function f, don't need a comma there, if f of c equals 0. In other words, you are looking for the x value, what input or x value makes the function or the equation equals 0. That's what you're looking for. So, for example, I want to find the 0 of this function. F of x is equal to 5x plus 20. Okay. Remember, f of x you can consider just as y, right? It's the same thing. But we want to figure out what does this have to be to where this whole thing equals a 0. Don't fall for the rookie mistake of plugging in 0 for x. Don't do that. That's not what you're doing. We don't know what x is. We want the entire thing to equal 0. Okay, so the way you do that is you actually just take that 5x plus 20 and you set it equal to 0 so you can solve it. And then you solve it. Okay, so I'm not going to write out every step here, but subtract 20 from both sides. 5x equals 0 minus 20 is negative 20. Multiply both sides by 1 over 5, or just divide both sides by 5. Negative 20 divided by 5 is negative 4. So negative 4 is the 0 of this function, because if you plug in negative 4, it ought to equal 0. 5 times negative 4 is negative 20. Negative 20 plus 20 is 0. So see, it works. Okay, let's do one more. Let's find the 0 of the function negative 3x plus 13. And we said, again, we're trying to find the x value that makes this entire thing equal 0. So I'm going to set that equation, or that expression, equal to 0. Okay, I want to get x by itself. By the way, you don't actually have to do the addition principle first, right? I don't have to subtract 13 first and then divide. I could do it in the reverse order, so I'm going to do that. Why not? Let me add, I'm sorry, I'm about to do the addition principle first. Let me divide both sides by negative 3, or divide everything by negative 3. Okay, I'm going to write this one out. I want you to see that it doesn't matter the order that you apply these principles, but usually we do addition first, addition, subtraction first, and then multiplication, division. But anyway, negative 3x divided by negative 3, we'll cancel out the negative 3, I'm left with x. Positive 13 divided by negative 3 is negative 13 over 3. 0 divided by negative 3 is 0. Okay, and then now I want to get x by itself, so I need to add this negative 13 over 3 to both sides. So I'm doing the addition principle last. Cancels. X equals 13 over 3. Same answer that you would get if you, well, sure, why not? We have time. I could have, and I'll do it quickly, subtracted 13 from both sides first. And then divided each side by negative 3, and gotten the exact same 3. Two negatives make a positive, right? So the last thing I want to show you real quick is that it doesn't matter the order. You could divide, then multiply. There I go saying it wrong again. You can divide and then add or subtract, or you can add or subtract and then divide or multiply. Okay, it doesn't matter the order. You'll get the same answer. Okay, so that's section 1.5. Or I'm sorry, section 1.5.